again, what we're going to be doing is we're going to have a bunch of problems that are not quadratics. They're going to be a degree higher than 2. But we're going to kind of treat them like quadratics and be able to factor them like quadratics, except they're just not going to be quadratics. And we're going to have to take it another step further in order to come up with those solutions. But the strategies that we use with factoring and factoring quadratics will apply to the ones we're going to look at for objective 1. Okay? Objective 2, to be honest with you, we've kind of already done, is rational equations where we're going to just multiply through by the common denominator, and then we'll look at objective 3 on Monday. So, here's the first problem. You have 5y times the quantity 3 minus y times the quantity 4y plus 1 squared equals 0. So the thing that's nice about a problem like this, and you are going to see some of these in your homework, is that one side's already equal to 0 and it's factored. So it's almost like it's in factored form right now, like the work has already been done for you, and so you use zero product property and just set all those factors equal to 0 and solve. So do that. So I've got 3 equations basically. 5y equals 0, 3 minus y equals 0, and 4 plus y all squared equals 0. Now, on the first one, of course, I get y equals 0. Second one, I get y equals 3. Technically, what I should do is square root property over here to undo the squaring. Of course, the square root of 0 is just 0. But I wanted to put that up there if we're ever in a situation where it's not a 0 for some reason. So in reality, all I'm really doing is finding what 4y plus 1 equals 0 equals is negative 1/4. So those are my 3 answers. How many had that? Okay. So you're going to have a couple problems like that in your homework where it's already in factored form. You just have to separate them and set them all equal to 0. We need to look at 2 other examples today that aren't going to be quadratics and require a little more work than just setting them equal to 0. So I want to focus on those. Okay? And this one is the one I want to start with. Fortunately, one side is already equal to 0, so that part's already been done. But if you notice here, you know what? This is not a quadratic, right? What's the highest degree? 3. Do you know what that's called when it's the degree 3 is the degree is 3? It is a cubic. Very good. It is a cubic. Our goal should be factor and solve. Whenever we see these types of polynomial equations, we want to try to factor them and break them down. What type of factoring should we use when there's 4 terms? Grouping. Okay. So if you remember grouping, it goes a little something like that. Please go ahead and attempt to complete this problem. Look at what we have so far. Okay. On this first group, what is the greatest common factor? 25y squared. What is the greatest common factor over here? Negative 1. The first step, that's what you should have. Okay? Notice that I have a y plus 4 in common, and I'm left with a 25y squared minus 1. Okay? That's this left over. How many had that much? Okay, good. Can I keep going? On what one?
Is it a difference of squares?
It is a difference of squares. So we can keep factoring here. This is still a difference of squares. Now, let's say you didn't do that. Let's say you didn't realize that, and you just set this equal to 0 and solve using square root property. That is also acceptable since there is no y term. You could do that. But, just generally speaking, when we solve these types of equations, you want to factor as far as you can go. And after you do the first round of factoring, you want to see if there's a second round that you can do, and there is. So what would this factor into as a difference of squares? 5y plus 1, 5y minus 1. Okay, so now it's completely factored. So now we've got it to the point where the first problem that we did, that's the same point that it started at. Set each of them equal to 0 and solve. Okay, this one's going to give me what? Negative 4. What's this one going to give me? 1/5 and negative 1/5. Okay, if you wanted to put plus or minus 1/5, that's okay too. Now, it's not a coincidence that this is a cubic degree 3 that I get 3 solutions. It should work like that. Occasionally, we'll get what's called a double root, where one answer kind of appears twice, but generally speaking, we should get the same number of answers as the highest power. Okay? It's working now. Okay. Here's our next one. This one is 18x to the fourth minus 21x squared plus 3 equals 0. Now, when we have something where the highest degree is 4, it's actually, does anybody know the name of that type of function?
Quadratic.
No, quadratic is highest degree is 2.
Quad is 4.
It is, right. So this is where it gets interesting because it's not.
Is it tetric?
No, it is not. It's called a quartic.
Yeah.
Quartic. But you know what? The fact that you said quadratic is interesting because quad does mean 4, but yet we know that's degree 2, so English. All right, here's the way I'm going to show you how to do this. You can actually factor this the way it is right now and treat it like the trinomials that we've seen as quadratics. But there's a kind of a nuance to it. And so I'm going to show you how to do that. What I want you to think about is I'm going to actually substitute z in for x squared. And then if you notice this equation here, this becomes 18z squared, since x squared squared is x to the fourth, and z is x squared. So now this looks like a quadratic. So I can factor that like it's a regular quadratic. And then what's going to happen is after I do that with the z's, I'm going to substitute the x squared back in. That is one way to do this problem. Now, the other thing that you could do is factor it just like this, but you have to understand when you create those two sets of binomials, the front terms are going to be x squareds, not x's. Normally we have like in this one, we're going to have a z in the front on both terms. In both binomials, there's going to be a z, since I changed it to a quadratic. If you want to factor it just like this, the front term is just going to have to be x squareds. But you'll see after I substitute back in what I'm talking about. I'm not restricting you to do it one way or the other, but I thought I haven't shown you this way yet, and I thought for some of you, you might like that. Okay? So what we really are going to do is factor this first equation. And there's a greatest common factor, it's 3. Okay, so now we're pretending the problem is this. So what I want you to do now is factor what's left inside the parentheses, however you want. Whether you want to use grouping or guess and check or box method, I don't care. Factor that out. I'm going to tell you right now that I'm going to do grouping. Here's how I would start this if I was going to use grouping. We're going to basically just ignore this 3. It doesn't have any impact on the rest of the problem because there's no variable with it. So my first move is to take 6 times 1 and find factors of that add up to -7. And they are -6 and -1. So I'm going to break this middle term up using these two factors. So essentially what I get now is -6z minus 1z. And so I've got my 4 terms and I'm going to group them. Throw my parentheses in there and put a plus sign in just like we did before. Greatest common factor here is 6z. Greatest common factor leading is a 1 or -1. So I want to make sure that I have a z minus 1 and a z minus 1 so that I can bring the 6z minus together. And that's the factored form with the z. Right? And this is the point where I'm going to substitute the x squared back in. Okay? And I'm really dealing with, the real problem is 6x squared minus 1, x squared minus 1. So I just substituted this back in for there, and that's where I got my new equation from. Now, this is what I was saying at the beginning, okay? If you notice here, I basically can factor this, make it 6x to the fourth minus 7x squared. It's the same concept, it's just those front terms are x squareds instead of x's, or z's in this case. So you don't necessarily have to substitute. I think for some of you, it's helpful to see it that way though, okay? And again, I'm not going to tell you which way you have to do, but you could have gone from here to here with the right number of steps, okay? And it's okay to do that. There's one last thing I need to do though, again, because this is not completely factored anymore. Where's my issue? Where can I keep going?
Second one. Difference is squared.
Yeah.
Difference of squares right here. What would that factor to?
Plus one, minus one. X plus one.
X plus 1, x minus. Okay. So here's where I'm at now. Now it's completely factored. Okay, and I can set all of those things equal to 0 and solve. So if you hadn't gotten that far, finish it from there. I set them equal to 0, and I actually just set this will give me positive 1, this will give me negative 1. We need to focus on this one, because this one is a little bit different. Okay, it doesn't come out as nice. First off, I can divide both sides by 3 and not have to worry about it anymore. But then I can solve this using square root property. Right? I'm going to add 1 to both sides and divide by 6. And so x squared equals 1/6. I skipped a couple of steps there. Add 1, divide by 6. What do I have to do to get x here? Square root both sides plus. Okay, let's understand what we really have. The square root of 1/6, that's the square root of 1, which is just 1. And then the bottom I have the square root of 6. Think back to what you know about radicals. Can't have radicals in the bottom. No radicals in denominators. So how am I going to get rid of that radical in the denominator? Multiply top and bottom by, go ahead, square root of 6. Multiply top and bottom by square root of 6. On top I have square root of 6. On bottom I have the square root of 36, which is what?
6.
Just 6. So what that does to me is it allows me to get rid of a radical on the bottom. Okay, rationalizing denominators is not something we've really talked about in here. You have done it before in your Algebra 2 class. Okay, just remember, if you run into a situation where you have a radical and a denominator, what you're typically going to do is just multiply the top and bottom by whatever that radical is, and that basically makes that radical cancel out, because this is radical 6 squared. Square root and squaring cancel, so that's where the 6 comes from. Okay, and now I have 4 answers, excuse me. Okay, and again, this is 4th degree, 2 answers here, 2 answers there. Okay, that's about as complicated as these problems will get on you today.